Welcome to this lesson on energy levels and electron shells. In this video, you'll learn about the fundamental concept of electron shells, which are the distinct energy levels where electrons exist around an atom's nucleus. Understanding electron shells is essential for grasping how atoms behave and interact with each other in chemistry. Electron shells are defined as energy levels where electrons orbit around the nucleus of an atom. Think of them like invisible layers surrounding the nucleus, similar to the layers of an onion. Each shell represents a specific, fixed energy value. Electrons cannot exist between these shells. They must occupy one of these discrete energy levels. This quantized nature of energy is a fundamental principle in atomic structure. The principal quantum number, represented by the symbol n, is used to identify and label different electron shells. This is a positive integer that tells us which shell an electron occupies. The value of n can be 1, 2, 3, 4, and so on. The principal quantum number is the primary descriptor that defines the shell and its associated energy level. It's the most important quantum number when first learning about atomic structure. The main electron shells are numbered sequentially starting from the shell closest to the nucleus. The first shell is labeled n equals 1, also known as the K shell. The second shell is n equals 2, called the L shell. The third shell is n equals 3, the M shell, and the fourth shell is n equals 4, known as the N shell. This pattern continues for larger atoms with more electrons. Each shell can be identified by either its n value or its corresponding letter designation. Visualizing the shell structure helps us understand how electrons are arranged around the nucleus. The nucleus sits at the center of the atom. The first shell, n equals 1, is closest to the nucleus. Moving outward, we find the second shell, n equals 2, then the third shell, n equals 3, and the fourth shell, n equals 4. Each successive shell is farther from the nucleus. This arrangement creates a layered structure where electrons occupy different distances from the atomic center. An important principle to understand is that energy increases as the shell number increases. Electrons in shells farther from the nucleus possess more energy than those closer to it. For example, an electron in the n equals 4 shell has more energy than an electron in the n equals 3 shell, which has more energy than n equals 2, and so on. This relationship between distance and energy is crucial. Higher n value means higher energy. Electrons naturally prefer to occupy lower energy shells when possible. Each electron shell has a maximum number of electrons it can hold, determined by the formula 2n squared. For n equals 1, the capacity is 2 times 1 squared, which equals 2 electrons. For n equals 2, it's 2 times 2 squared, which equals 8 electrons. For n equals 3, 2 times 3 squared gives 18 electrons. And for n equals 4, 2 times 4 squared equals 32 electrons. This formula allows us to calculate the maximum capacity of any shell, though in practice, shells may not always be completely filled. Let's review the key concepts. First, electron shells are labeled by the principal quantum number, which takes values of n equals 1, 2, 3, 4, and higher. Second, energy increases as you move to higher shell numbers, with shells farther from the nucleus having greater energy. Third, each shell has a maximum electron capacity given by the formula 2n squared. Finally, electrons fill lower energy shells first before occupying higher energy shells, following the principle of minimum energy. These foundational concepts will help you understand more complex topics in atomic structure and chemical bonding.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.